Welcome to EDU World Space.
In this problem, we're given the EMF of the battery is 1.5 volts. It has a negligible internal resistance, and when a certain resistor, which is unknown, let's say it has value R, is connected to this battery, it dissipates a power of 0.0625 watts. And in part A of the problem, we're asked what power does the resistor consume if it is now connected to a 12.6 volt car battery. So we can solve this problem by using equation 25.18, which states that P is equal to the terminal voltage over the resistance squared. Over the terminal voltage squared over the resistance, not resistance squared, sorry. And so we need to make two steps in order to solve this problem. So first, we'll find R, and once we find R, then we'll try to find the power that's dissipated by this resistor given the new battery. So right now we have information about the old battery and the power that's dissipated when this resistor is connected to the old battery. So we have P and we have V, and we want to find R. So R is VAB squared over P, which is, since the internal resistance is negligible, it's exactly the EMF of the battery, which is 1.5 volts squared over 0.0625 watts. And this is 36 ohms. Okay, so now we have the resistance. So using the very same equation, we want to find the power dissipated, but this time we know VAB. So this is for the new battery, the 12.6 volt, was it? Yeah, the 12.6 volt battery, and we now know the resistance. So let's put that in. .36 ohms, and this gives us 4.41 watts of power that's now dissipated. And now we're going to go to part B of the problem. Now part B of the problem says that the resistor is connected to a battery and now consumes 5 watts of power. What is the voltage of the battery? So again, it's just the very same equation. And this time we're given P and R, and we're asked to find V. So over here we're given P and V, and we have to find R. Over here we're given V and R, and we have to find P. And now we're given P and R, and we have to find V. So applying the very same equation again, and then you just take the square root, right? So VAB is the square root of the power times the resistance. And let's plug in the numbers that we're given. So we're told that it's 5 watts of power that's dissipated, and we have our 36 ohms. And I forgot to mention, but a point that they state in the problem is that you assume that the resistance is not changing when you're changing your voltage, right? So when the power dissipated is changed, the resistance stays the same. So we can use the same value of R for all the three cases. And just taking the square root of this number, we have that the voltage is 13.42 volts. So that solves this problem.